Today we are solving quadratic equations using square roots. So this is very similar to when we were solving linear equations where we try to get that variable alone by performing inverse operations. So remember, the inverse operation of addition is subtraction, the inverse operation of multiplication is division, and the inverse operation of a square power is a square root. So we will do those inverse operations in reverse order of operations to get our variable isolated. So we want to go in reverse order. So that means we start outside the parentheses. We will add or subtract, then multiply or divide, and then we do the square roots. And when we take the square root of both sides, we have to remember to do a plus or a minus and then solve your two equations separately. So sometimes taking the square root of both sides will be the last step, but then sometimes that leaves you with an expression that still needs to be solved. And remember our concept of balance. Whatever we do to one side of the equation, we have to do to the other side of the equation. All right, so looking at example 1, we're trying to get x alone. It's inside parentheses with a plus 3. Outside the parentheses, we've got a square power. We're multiplying by -2, and we're adding 4. So the first thing we want to undo is this plus 4. So we want to get rid of everything outside of the parentheses first. So I'm going to subtract 4 from both sides. So on the right-hand side, -68 minus 4 becomes -72. The next thing we want to do is outside the parentheses, this is multiplication right here. When there's nothing between the number and the parentheses, that means multiply. So to undo that, we would divide. So dividing both sides by -2, it cancels out the -2 on this side. On the right-hand side, we get 36. Next, we want to get rid of the square power that's outside of the parentheses. So remember, we take care of everything outside the parentheses first. So the inverse operation of square power is square root. I'm going to take the square root of both sides. When we take the square root of both sides, we have to remember plus or minus. So on the left-hand side here, that square power and square root cancel each other out. On the right-hand side, the square root of 36 is 6. So we get x plus 3 equals positive 6, x plus 3 equals -6. Because when we take the square root of both sides, that's when it becomes plus or minus. So we have two separate equations. So this equation on the left, to solve for x, I would subtract 3 from both sides. We do the same for our equation on the right. So on the left here, 6 minus 3 becomes 3. Over here, when we subtract 3 from both sides, -6 minus 3 becomes -9. Moving on to number 2. So x is inside the parentheses. We want to first get rid of everything outside of the parentheses. We've got multiplication, square power, and we have subtraction. So we want to get rid of the subtraction first. We would add 2 to both sides. And then outside the parentheses, we're multiplying by 1/3. The inverse operation of multiplying by 1/3 would be to multiply by the reciprocal. So multiply both sides by 3. So 3 and 1/3 cancel each other out. And then to get rid of this square power outside the parentheses, take the square root of both sides. When we take the square root of both sides, we have to remember plus or minus. So we've got two different numbers over here now, the positive square root of 9 and the negative square root of 9. On the left-hand side, that square power and square root cancel each other out. So I'm going to have x minus 4 equals positive 3, and x minus 4 equals -3. And then we solve those two equations for x. So to get x alone now, I would add 4 to both sides, and I would do that with both equations. 3 plus 4 gives us 7, and then -3 plus 4 gives us 1. Recall how to simplify square roots. Remember that we can break them up into our good root, bad root, and we can simplify that good root. Following that same order as before, for number 3, we want to isolate x, get rid of everything outside of the parentheses first, add 2 to both sides, divide both sides by 3, and then we take the square root of both sides. Now this time, when I have the square root of 6, 6 is not a perfect square, so I'm just going to be getting an irrational answer. So on the left-hand side, that square root and square power will cancel each other out to give us x plus 4. And then lastly, subtract 4 from both sides. So we get x equals -4 plus or minus the square root of 6. For number 4, we want to get rid of everything outside of the parentheses first. So subtract 8 and then divide both sides by -5. And then to get rid of that square power, we take the square root of both sides, remembering plus or minus. 10 is not a perfect square, so that does not, we can't break it up into two separate equations because we're going to get irrational answers. On the left, square power, square root cancel each other out. The last thing left to do to get x alone is to add 2 to both sides. So we get x equals 2 plus or minus the square root of 10. So this is two different numbers here. We're just kind of smushing it together for like the lazy way of writing it. So 2 plus 10 would give or 2 plus the square root of 10 would be one of our answers, and then 2 minus the square root of 10 is our second answer. So we're just writing that in shorthand here using that plus or minus. Number 5, we don't have parentheses this time, all right? So we still want to perform inverse operations in reverse order to get x alone. So x is squared, then multiplied by 3, and then we're subtracting 4. So we'll do that in the reverse order. We'll undo that in the reverse order. So first add 4, and then divide both sides by 3. And then we take the square root of both sides to get rid of that square power, remembering our plus or minus. So we get x equals plus or minus 5. In number 6, subtract 8 from both sides. So -41 minus 8 becomes -49. And then this negative sign in front is like times -1. So to undo that, we divide both sides by -1. So that gives us x squared equals 49. To get rid of that square power, we'll take the square root of both sides, remembering our plus or minus. We get x equals plus or minus 7. Number 7, we need to add 11 to both sides. That gives us x squared equals 18. And then taking the square root of both sides to get rid of the square power, remembering our plus or minus, we get x equals plus or minus the square root of 18. Now 18 does have a perfect square factor of 9, so I'm going to break up 18 into 9 and 2. The square root of 9 is 3, so we simplify our answer to x equals plus or minus 3 root 2. For number 8, the first thing we need to do to isolate the x squared, or to isolate x squared, is divide both sides by -4. And then to get rid of that square power, we take the square root of both sides. When we take the square root of both sides, we have to remember the plus or minus. So on the left-hand side, square power and square root will cancel each other out. On the right-hand side, we get plus or minus the square root of 75. 75 does have a perfect square factor of 25. So I'm going to break down 75 into 25 times 3. We've got our good root, bad root. We would simplify the square root of 25 to 5. So our simplified answer is x equals plus or minus 5 root 3. For number 9, to isolate our x, first thing we have to do is add 100 to both sides. Next, we would divide both sides by 4. And lastly, to get rid of the square power, we take the square root of both sides. So remember your plus or minus when you take the square root of both sides, so we get x equals plus or minus 5. For number 10, divide both sides by 17. We get x squared equals 12. Take the square root of both sides, remember plus or minus. 12 does have a perfect square factor, so of 4. We can break that down into 4 times 3. And the square root of 4 can be simplified to 2. So our final simplified answer is x equals plus or minus 2 root 3.